So I'm now going to go over the second part of the graphing practice homework. All right. And again, I'm going to use this attack the graph sheet. All right. I went over this at the beginning of the first video. All right. But again, you should write down what the slope means next to the graph. All right. Use the flow chart to describe the motion and write that down, and do this before you start doing the questions. And the reason is your intuition is going to connect with one of these types of graphs. Most people's intuition connects more with displacement graphs. So your knee-jerk reaction would be to answer the questions as if it's a displacement graph, and it's going to be a bloodbath if you do that. So this is a method to get you to slow down. All right. So the first thing you're going to do is write down what the slope and the area mean to remind yourself, right? So the slope of a velocity graph tells you about acceleration. And the velocity, and the area tells you about displacement. All right, and specifically the areas we're talking about are between the axis and the line. Or in calculus, we'd call it the curve, but we can't have curves in this class because you need calculus to deal with non-uniform acceleration. All right, and then you're going to write down what's happening in each section. All right, so for velocity graphs, if it's above the axis, it's going in the positive direction. And then you can tell if it's slowing down or speeding up based on whether it's approaching the x-axis or moving away. So let's go ahead and write this down. So right here we have negative direction because it's below the axis, positive direction, positive direction, positive direction. All right. And then we're going to look at, is it approaching the x-axis or moving away? This is approaching, so this is slowing. This is getting away from the x-axis, so it's speeding. All right. This is constant because it's constant, a horizontal line. And this is approaching the x-axis, so it's slowing. Now we are prepared to answer the questions. All right. When is it going in the negative direction? Whenever it's below the axis. So that's between 0 and 3 hours. Okay. When does it turn around? Right there. When it goes from the negative direction to the positive direction, it stops and turns around. So it's right at 3 hours. All the object intervals when it's slowing down. Whenever it's approaching the x-axis, it's slowing down. So between 0 and 3. And also, it's approaching the x-axis between, let's see, it's 10 and 12. When is it speeding up? It's speeding up when it's going away from the x-axis, so that's between 3 and 6 hours. What distance? All right, so let's get back to the attack the graph thing. If they ask you about displacement or distance traveled, which is a related quantity, you're going to find the area. All right, from 3 to 10 hours. That wasn't a very nice thing I did. Oh no, but 3, yeah, but here it is. 3 to 10 hours. We need all of this area, okay? So the area of this triangle is going to be base times height over 2. So that's going to equal, the base here is 3. The height is 30. And that's all over 2. 3 times 30 is 90. 90 over 2 is 45. This has an area of 45 kilometers. Okay. This rectangle here, all right, it's just going to be base times height. So the base is, see, it's going between 5 and 10. And the height is, again, 30. Oh, you messed up the units here. Let me fix that. All right. So 5 times 30 is, 1,550? So this area here is 150 kilometers. So the total distance traveled is going to be 45 kilometers plus 150 kilometers. And that equals, 195? And somewhere here I made a mistake. What did I do? Let's see. So this is between 6 and 10. So this is actually only 4. 4 times 30, this is only 120. Sorry about that. And this is also 120. Safe place to make mistakes. I'll do it every day. So this ends up being 120 and 165. Ooh, I fixed it. Okay. All right. What is the object's acceleration at 4 hours? All right. For a velocity graph, if you want to find acceleration, find the slope. So at 4 hours. Again, people really want to use this exact point, but you don't have to. You can pick any points on this line. I'm going to pick these 2 points because they seem easy. So the rise here is 30. And the run here between this first and last point is 3 to 6, 3. So this acceleration equals the slope, and that is 30 kilometers per hour all over 3 hours. And this ends up being 10 kilometers per hour squared. Okay. All right. And then the average velocity. I have not talked about how to do this, so if you get this wrong, it's my bad, not yours. But the formula for average velocity, which we have not given you, is change in displacement over change in time. Okay. And from 5 to 10 hours is a nasty amount of freaking displacement. You actually have to find this area here from 5 to 10 hours. So it's this area and all of this. I guess this is really, so I need the area of this little triangle, this thing, and all of this. All right. So, all right. So let's see. We've got to use the area all over the time. The time is 5 hours. The area is going to be 120 kilometers because that's that big rectangle here. Plus this tiny rectangle here has a base of 1. This is a fraction. Look at this nice compound fraction I'm about to do for you. All right, 1 times, and the height is 20 all over, oh, but there's no 2. Yeah, there's no. So 1 times 20 for that little rectangle. And then this tiny triangle, which is also on top of this fraction, has a base of 1. I'm not putting units in, it's getting too cluttered. And a height of, from 20 to 30, of 10 all over 2. Okay, so 1 times 20, this thing here has an area of 20. This little tiny triangle here has an area of 1 times 10 over 2 is 5. All right. And all of these are on top of this. So I have 120 plus 20 plus 5. That ends up to be 145 all over 5 hours. And 145 over 5 is 29. All right, to sum up what we did, we had to find all of these areas, all this area here and all of this area. And that was the top of the fraction, and the bottom fraction was time. Again, I did not tell you about this ahead of time, so good job. All right, let's just quickly talking about this. All right, 2 things you've got to be able to do are describe something moving at constant velocity. So the way you do this is you say, all right, this has a constant velocity. Start with the velocity graph because that is because that's how we talk about motion. Then we're going to use slope to go this way. The slope of this line is 0, so this has 0 acceleration. All right, and if this is going in the positive direction and constant velocity, then the displacement graph is gonna look like this. Okay. One way to do that is with area. and say like as area, because we go this way for area, boop, that this area here, as time goes on, you get bigger and bigger chunks of area, but they all change at a constant rate. So this goes like that. And we saw an animation like that at the beginning. And then the second description is positive object with positive constant acceleration. So they're telling us this. If without any other information, this is speeding up like this. And a constant positive acceleration is going to look like this.